All right, this week we're going to be talking about the inner planets of our solar system. We've already talked a bit about the general solar system, but now we're going to concentrate on the inner planets. As usual, remember that red slides mean you have to take notes. You should have your inner planets handout to go along with this, and don't forget to look for the owl. At the end, make sure you tell me where the owl is and summarize what you've learned in a few sentences. All right, so you remember my very eager mother just served us nachos, so I bet you could probably help me out here with the inner planets: Mercury, Venus, Earth, and Mars. All right, so here is a fairly good scale model here of the solar system, and we have the sun over on the left here, and we have the distances of the planets in astronomical units, or AU, and you can remember from last week's homework that basically the AU, an astronomical unit, is the average distance from the sun to the earth. So it would be this distance from here to here. That would be 1 AU, the distance from the sun to the earth. So, based on that, what planet is this? It is 0.39 AU from the sun, so we know it is less than the distance from Earth to the sun, and that's what it looks like in the sky right there. You can very clearly see this planet in the sky with your naked eye when it's in the right place, and you might have guessed it, that is Mercury. All right, so let's talk about Mercury.
Mercury. Once believed to be two separate stars, it is the smallest planet in our solar system, barely larger than the Moon. Surface temperatures can go from a scorching 800 degrees Fahrenheit to a frigid 300 degrees below zero. 48 million miles from the Earth, Mercury is dangerously close to the Sun, making it possibly the most difficult of the 8 planets to reach. So will we ever unravel the mysteries of this tiny world? Welcome to Space School.
All right, so this is the symbol for Mercury, and as you saw in that little video clip there, Mercury is named after the god of commerce and speed. Now, there's a reason for that. If you look in the center right here in this closest orbit, you can see that Mercury goes really, really fast around the sun. So that's a good reason why he was named after the Greek god of speed. Now, here's a question for you. Forget about the temperature of the planet, atmosphere, stuff like that. What would you think about spending a day at school on Mercury? Well, the thing about that is that 1 day on Mercury is equal to 58.6 Earth days. Now, obviously an Earth day is the time that it takes the Earth to go around once. That takes 24 hours. We're used to that amount of time. But the amount of time that it takes Mercury to go around one time is equal to 58.6 of Earth's days. All right, here's Earth on the left, and there's Mercury on the right. You can see Mercury is quite a bit smaller than Earth. Mercury is the smallest planet in the solar system, and you can see Mercury going by right about there. That's what we call a transit. Basically, the idea is Mercury is obviously in between the Earth and the Sun, so sometimes we can actually look from Earth, and we can't see this with the naked eye, but with special telescopes and lenses, you can sometimes actually see Mercury going across the surface of the Sun. And you can see here that Mercury's orbit actually takes it in its closest part to the Sun, takes it as close as 27 million miles from the surface of the Sun. And that might sound like a really long distance for what we're used to, but as far as planets go, that's actually really close to the Sun. So because of this, the Sun would actually appear 3 times bigger in the sky than it does here on Earth. So remember that really slow day? Remember it takes like 50-something days for Mercury to spin around once? Well, think of what the implications of that are. Basically what that means is that one side of Mercury is facing the sun for a really long time, and the other side is facing away from the sun for a really long time. So you can imagine the sun-facing side, the day side, it gets really, really hot, and the night side gets really, really cold because it's facing away from the sun for so long. So the temperature of Mercury when you're facing the sun is 800 degrees Fahrenheit or 420 degrees Celsius. Now remember, The boiling point of water, boiling water is only 100 degrees Celsius. So this is 4 times the temperature of boiling water. Now, on the dark side, on the night side, it gets very cold. It gets down to negative 279 degrees Fahrenheit, which would be equivalent to negative 173 degrees Celsius. And again, the freezing point of water is 0 degrees Celsius. So this is 173 degrees colder than ice. All right, so time to write some stuff down in your notes. The main things to remember about Mercury: we have very close to the sun, no moons here, little to no atmosphere, lots of craters, very hot in the day, very cold at night, has an 88-day year, so it travels very fast. Remember, we have a 365-day year, so Mercury is only 88 days, and 1,407-hour day, really long day. All right. What's this one? This is another planet that you can easily see up in the sky. This is about 0.7 astronomical units from the sun, so a little bit more than half the distance from the Earth to the sun. Well, you might have guessed it. It's our next planet, Venus. This is the closest planet to Earth. So, let's talk about Venus. Okay, so this is Venus as it looks in the sky, and it's right there. It's kind of an interesting thing. When you go outside and look at the night sky, a lot of times what you'll see is some little spots up there that kind of look like stars, but they kind of stick out, and they look quite a bit brighter, noticeably brighter than other stars. If that's what you're looking at, you're probably looking at a planet a lot of times. Another way that you can figure it out is that the stars kind of have that twinkling thing going on, but planets do not. They have kind of a steady light that you can see. And so if you look up there and you look for that, what you're going to see some of the time is Venus. And Venus is the brightest object in the sky other than the moon and the sun. So which one's larger, Venus or Earth? Do you know? Well, take a look at this picture. This is pretty much to scale here, and you can see that Earth is a little bit larger, but they're very close together. And because of this, and because of many other facts, including the fact that they're made out of basically the same materials, and we think that they were formed at pretty much exactly the same time and things like that, and they're very close together, we consider Venus to be Earth's sister planet. So, how would you like to take a trip to Venus? Sounds like fun? Well, okay, let's think about that a little bit. Venus has a constant temperature of about 480 degrees Celsius, which is 864 degrees Fahrenheit. This makes Mercury look like a pretty nice place to live. And an interesting thing here is that what we should expect is that as we get further away from the sun, which is a big ball of fire and really hot, as we move further away from that, it should get colder and colder. But you'll notice that Venus is quite a bit hotter than Mercury was. Well, the reason for this has to do with Venus's atmosphere. So this is because of Venus's atmosphere. Venus has a very thick atmosphere that has a lot of greenhouse gases like carbon dioxide and methane and sulfur and things like that. And these gases will really retain a lot of heat. So basically what the greenhouse effect is that heat comes in from the sun and heat tries to kind of get back out. You could think of the idea of like heating up a frying pan on the oven and then turning off the stove. And if you put your hand over the frying pan, you can kind of still feel some heat kind of coming back out of the frying pan. And that's what happens to planets too. But because of Venus's atmosphere, it kind of traps all that heat in there and doesn't let it out. We see a very similar thing happening here on Earth with CO2 and water vapor and methane gas that we have in our atmosphere that also traps heat in here. Now, fortunately for us, it's not anywhere near as bad as Venus. Venus is really bad as far as this goes, and this is sort of something that can show us what the extreme effects might be of a greenhouse effect. But again, we don't have anywhere near this bad of an effect on Earth, but we do have something similar going on. So the thick atmosphere really traps a lot of heat, and that's what makes Venus kind of unexpectedly the hottest planet on Earth, considering that it's not the closest one to the sun. So speaking of that atmosphere, well, there's a lot of carbon dioxide and sulfur compounds in here, and that would basically kill you pretty much instantly. Those, especially the sulfur, can be very poisonous to you. There's really not a lot of oxygen there, so trying to breathe on Mercury would be a problem. And not to mention that, but also the fact that it has such a thick atmosphere means basically you have more gases piled up on top of you. And so this creates a huge amount of pressure that would basically crush you. So yeah, Venus is not the most fun place. Another interesting thing about this is that Venus rotates in the opposite direction of all the planets, and this is sometimes something that is questioned about how this happened and things like that. But basically the idea is that it seems like something probably ran into it while it was forming and caused it to start spinning in the other direction. A day on Venus is 243 Earth days, and a year on Venus is 224.7 Earth days. Hold on a second, did you catch those numbers? That means that a day on Venus is longer than a year on Venus. In other words, the time that it takes Venus to rotate one time around is actually longer than the time that it takes to orbit around the sun. All right, so our basic facts about Venus. Venus is Earth's sister planet. It's almost the same size as Earth. Its atmosphere is mostly CO2 and sulfur. It's very hot due to greenhouse effect. The day is longer than the year, and it rotates opposite of other planets. We can do this in class. All right, there's our home. All right, so one of the really important things about Earth, and the reason why it's our home, the reason why we're here to talk about it and study it in the first place, is because Earth is in what's called the Goldilocks zone, or what's also known as the habitable zone. So you might remember from Goldilocks that Goldilocks went and ate the porridge, and one of the porridges was too cold, the other one was too hot, and the other one was just right. Well, we're basically in that same situation because our position right here is in just the right distance from the sun, 1 astronomical unit away, just the right distance from the sun so that we are not too cold and not too hot. Now, the question that you should be asking here is not too cold and not too hot for what? And the answer to that is that we are just the right temperature so that we can have liquid water on Earth. There's a few different planets out there that seem to have water on them, including Mars. But Mars's water is, for the most part, frozen. And if you get too close to the sun, all the water kind of evaporates away. So we're right in that sweet spot where we can have liquid water. And liquid water is very important for life. All right, so this is one of the most important things to know about the Earth, that it is in the Goldilocks or the habitable zone, and this is the distance from the star that is the right temperature to support life, which really means it's the right temperature to have liquid water on the planet. The impact theory, this is kind of an important idea too. We'll talk about this more in class, but this is basically how we think the moon was formed. And this is the idea that at some point there was another planet that basically crashed into Earth. And I'll show you a great little animation of this. I really like this video. All right, so we're going to learn about the missions to the moon. We'll do a little bit of that in class, but the main thing that I want you to know is that they were the Apollo missions, and these were the first missions to the moon. All right, let's talk about Mars. Mars is always a fun planet. So, Mars is first of all, smaller and less dense than Earth. It's quite a bit smaller than Earth, almost half the size of Earth. There we go. It appears red because of rust. That might be a little bit surprising, but there's actually a lot of iron in the soil, and we actually see this on Earth quite a bit. When we have some iron in the soil, it can make the soil kind of look a reddish color, but basically Mars is rusted, just like a rusty nail or something like that. All right, Mars has ice caps on both poles, the North and South Pole, frozen water, but we have a very exciting announcement that has happened. This is the reason why I'm saying that is because as of the recording of this video, this announcement just happened yesterday. There is actually, NASA has now confirmed that there is actually liquid flowing water on Mars. This is very interesting. The reason why it's able to be liquid even though it's not in the habitable zone is because it's very salty water, and salt in water makes the water freezing temperature much lower. All right. What you're looking at is the largest mountain in the entire solar system. This thing is pretty amazing. This is Olympus Mons. This is the largest volcano in the entire solar system. That's what it looks like from the side. This is Mount Everest, the largest mountain on Earth. That's the normal height where a plane would fly. And that's the height of Olympus Mons. So you can see that this thing is absolutely huge. The next time you look up in the sky and see a plane flying by, think of a mountain that's easily above that plane. These are the rovers, Spirit and Opportunity, the first two rovers that we landed on Mars. These are some pictures from Mars. This kind of blows my mind, the idea that we actually can look at pictures and videos from another planet. That's Mars right there. And that's another one. This is Curiosity. This is the most recent rover that we've put up on Mars. And the main reason for Curiosity was to look for signs of past life on Mars. Basically, Curiosity was looking for whether or not Mars has either presently or in the past has had the ability to support life on it. It's not that it actually found life as of right now. It's not that it was even necessarily looking for life. It was just looking for the possibility that Mars could support life. Then the next step in that equation would be to actually look for life on Mars. And the answer to that is that yes, Mars, we don't know if it has ever had life on it necessarily. We haven't found evidence of that yet, but we do see a lot of signs that Mars could potentially have had life on it. Things like running water and things like that, and organic molecules. So we do know that it's at least possible that Mars could have life on it. And these are Mars's moons, Phobos and Deimos. That's Phobos, and that's Deimos. You can tell Phobos because it's got this big, huge crater in it. You may notice something at this point, and that is that we really haven't talked too much about moons here. Earth has one moon, Mars has two moons, and then that's it for moons in the inner solar system. This will be very, very different when we get to the point of talking about the outer solar. All right, so there you have it. The inner planets, what are also called the rocky or terrestrial planets. That means that they're made of rock. As we'll see, the outer planets are made out of gas, and that sort of separates the two. So Mercury, very close to the sun, has a fast orbit. When you think of that, you should think of Kepler. Remember, one of his laws was the idea that the closer a planet is to its star, the faster it orbits. We have Venus, that's Earth's sister planet. It has a really nasty atmosphere. It has the greenhouse effect that has made it the hottest planet in the solar system. It spins the wrong way. We have our home planet Earth. It's in the habitable zone. We know about the moon impact theory and the Apollo missions to the moon. And last but not least, we have Mars, which has the largest volcano in the solar system on it, Olympus Mons. And we should know about the rover missions and why they went there, and I will see you in class.